For this next part, we're going to create models using the histograms of the shorter half of the class and the taller half of the class. So in order to get those histograms, we could go to descriptive statistics and then under plots, select for the plots. But a way to do this is, since we've already run the descriptive statistics, if we simply click on the let me move that in. If we simply click anywhere on the output from our previous analyses, then it will open the menu back up with all of the information already saved. So rather than having to, for example, go back to descriptives and then do it all, I think I accidentally I accidentally deleted it. So I guess we'll have to do it again anyway, but theoretically it would have saved myself from having to move thumb length over. Again, we are splitting based on the height median split. And then now under plots, I want to go to the basic plots on the right-hand side and select the very first one that says distribution plots. And that will give us the histograms for each of these two groups for this variable. So I'm going to go ahead and hide the input options, and you can see we still have our descriptive statistics up top, and then now we also have these two histograms. So we have this histogram of thumb length in millimeters, which represents the data for the shorter half of the class. And then we have the data for thumb length in millimeters for the individuals who are in the taller half of the class. Okay. So at this point, we are going to use these histograms to create a model of the population that we think these data may have come from. Because again, we're not just interested in the sample that we have, we're really interested in a bigger group of people. We're interested in people in general, usually. But in this case, we're interested in the people that we think this data came from, which I believe was like Cal State LA students at the time. So let's go ahead, and the nice thing about JASP is we can copy and save images really easily just by clicking that little down arrow. So I'm going to go ahead and copy this, copy to clipboard. Now let me open up a new place to work so I can do some drawing. So I just pasted, and you can see it pasted that shorter half of the class. So let's see here. So again, this data that we see presented in this histogram is data of our sample. It's actual data from actual students in the class that we have data on. We're not interested in creating a model based on the data that it is based on the data we already have, but it's not meant to kind of summarize or be about the whole population, right? So our model is supposed to represent the bigger population based on what we know about this sample. So we want to label three things. We're going to label the shape, the center, and the spread. So the shape, looking at this, it looks like maybe it's slightly left skewed, negatively skewed. But overall, it's a pretty normal unimodal looking shape, right? Just by eyeballing it. So I would go ahead and just roughly draw in I think the population that, this data comes from, short people's thumbs, generally probably follow about this curve. And I think that that looks about right. Maybe a little bit more to the left, maybe, let me update this different color. So maybe yours is a little more skewed, right? That might be a little more accurate. But the thing is, we don't know. We don't know what that population looks like because we don't have data for the whole population. All we have is this sample. So I'm sort of guessing in this population, let's go ahead and we'll stick with this red one. Let me clean up a little. Okay. So let's go ahead and stick with this red one. So let's say I think this sort of distribution, I think most people who would be in the shorter half of classes, um, their thumb lengths, most people have thumb lengths between like 45 and 55. That would be what I assume about people in this population. I would assume that very few people have thumb lengths between 30 and 40, but some do. And there's probably few people who have thumb lengths longer than 60 who tend to be shorter people. But again, there's probably some who do. So I want you to imagine we're using this sample, but we're sort of imagining the overall shape of the whole population that we think this sample sort of came from, and ignoring, kind of the counts now, because we're imagining like this huge group of people. Probably most of them are going to be about, oops, there. There we go. So kind of ignoring this. So most of them will probably be about here. Fewer of them will be, out here, and then a lot fewer will be out here. That would be my guess about this population. Okay, so I'm just going to clean this up a little bit. So here's my shape. My center, if you remember when we talk about center, usually the best measure of center for us is going to be the mean. Right, so we got the shape. The center, I really want to label the mean, the population mean, because this model is representing my whole population. So if I were eyeballing this, I would say maybe somewhere around here. And again, this does not need to be perfect. So here, I've kind of identified what I think feels like the balancing point for these data. And it looks like it's maybe around 51-ish. If we look back at our, oops, not that one, at our data set, I'm going to use this 51.73, the mean, because again, we're talking right now only about the shorter half of the class. So I'm going to use this as kind of my guide, 51.73. That seems about right because I was saying it's around 51. So if I used, the sample mean was 51.73. So eyeballing this, I would guess the mean is probably somewhere around like 51 to 52. Now, we also want to talk about how spread out our data are. So we have an idea of, are they tightly clustered together? Is it really spread out? And so here, really, we want to talk about, sorry, my finger touched part of the screen. We want to talk about the standard deviation. I can draw that better. The standard deviation, again, of our population, because this model represents a population. So as just a visual depiction, a way to show that spread, that average spread, let me take a look back at our data. For our shorter half of the class, we're looking at about 6.1, so a little over 6. So if this is around 51, if I want to go a little over 6, I would want to estimate like 1, 2, 3, 4, 5, 6, like maybe somewhere around here would be about 6. Or because standard deviation is plus or minus, it's either direction, I could go about 6 the other direction, right? So that would be like 1 and then 5. So somewhere down around here. So either way, I just want to make sure that I have a way of sort of showing. So let me go ahead and I'm just going to make this a little dotted line to kind of like represent. That's about how wide, that up below. That's about how wide my standard deviation is, right? So our mean, our balancing point is in the center. Standard deviation, goes out to about here. So that means that most people, I think, are probably in this section, right? So on average, people have a spread based on this sample. We said it was about 6.1. They're spread out by about 6 and a little millimeters around this mean. So that means we have about 2/3 of our group is going to be in that section. And we'll talk more about why that's important later on in the course. So we've got our model drawn. Again, it's labeled based on the general shape of the population we think this sample may have come from, the approximate center balancing point, the mean of that population, and we have a visual depiction of the standard deviation as well. So I'm going to go ahead and write up the little Modelese portion. That's what I like to call this. It's like shorthand for this model language that we've been using, that we're starting to introduce. So I'm going to say, since this is the shorter half of the class, I'm going to say for people who are short, their thumb lengths, I'm just going to say thumbs or thumb, I guess, is about, I'm going to go ahead and say, let's say 51.8. So it's somewhere around there, 51, 52. It's about there, right? Or I guess it would be closer. If I want to be more accurate and I want to go with this 51.7, 51.7. Again, it's kind of up to you because, again, it's a model. It's not going to be exact. And then we also want to account for the fact that there's always going to be some error involved. So we have the short people's thumb lengths. My model is, I think short people's thumbs are probably centered around 51.7. But I also acknowledge that obviously not everybody's thumb length is going to be that length. And so if we're trying to predict the population, like anywhere plus or minus about 6 is pretty reasonable. It wouldn't be surprising at all if we got, as low as 6 lower, 51 minus 6, or if we got as high as 6 higher. If we got anything sort of in this range of our standard deviations, if we randomly pick somebody, that wouldn't really be very surprising because that's where most of our population falls, right? So this Modelese, let me write that out just so you can see what I'm actually saying. I'm saying, like it's a language, model ease. So when you see that, I'm talking about this kind of thing. So that's the written version of our model for this population. And we can see the visual depiction of our model for this population on the histogram. So I'm going to ask you to go ahead and I'm going to put the histogram for the taller half of the class down below in this problem. And I want you to think about it and maybe sketch out some things on some paper. And I want you to come up with the Modelese for the taller half of the class based on sort of what I just talked through.